Hello, my name is Siraji Dara and this is my CS2316 final project. First, I will talk about point of interest and purpose. I wanted to see how COVID-19 deaths varied among different ages and states in the United States from March 2020 to March 2021 in order to learn about what factors make someone most susceptible to death from COVID-19. My hypothesis was that older people are more susceptible to death due to COVID-19 and that there is a relationship between location in the United States and mortality. Once I decided my topic, I began my data collection process by searching for official health organizations with datasets on COVID-19 for each state and age group. I managed to find a CSV file containing information about conditions contributing to COVID-19 for each state and age group from 2020 to 2022. I then searched for an HTML file with information about state population and population density and found one with the population for each state in 2021 and 2022. Finally, I was able to find an API file containing the time period from March 2020 to March 2021 with cumulative data about COVID-19 for each state. Next, I will move on to my data cleaning process. In order to clean my downloaded dataset, I use the pandas module to read the CSV file to a pandas data frame and use functions like .drop, .rename, and .fillNA to deal with unwanted columns and missing data. I then use the .toCSV function to convert the data back to a CSV file. In order to clean my first web-collected dataset, I use the Beautiful Soup module to scrape the web page for relevant data and use useful functions like .findAll, .join, and .split to thoroughly clean my data. I then use for loops and .append to compile my list of lists of clean data. In order to clean my second web-collected dataset, I use the request module, .get, and .json functions to convert the JSON data into a Python dictionary, and then use the pandas module and pandas functions to convert the data to a data frame and clean the data. Now I will move on to the data analysis portion of this presentation. For my first insight, I found which 5 states contributed the most COVID-19 deaths from March 2020 to March 2021. This was insightful because it revealed information about the highest state death tolls, which I compared with information about the highest state populations in a future insight to identify similarities. So for my first visualization, I decided to make a bar graph showing the 5 states with the highest COVID-19 death toll from March 2020 to March 2021, and this was meant to accompany my first insight. As you can see, California and Texas are responsible for the most deaths and are responsible for over twice the number of deaths as Pennsylvania and New Jersey, which we will later see is partly due to California and Texas also having the highest populations among all states. For my second insight, I calculated the total number of COVID-19 deaths for the period among various age groups. And this was insightful because it shows that older people are more susceptible to death from COVID-19 than younger people. So for my second visualization, I decided to make a pie chart showing the proportion of deaths for the period for each age group, and this was meant to accompany my second insight. As you can see, individuals aged 55 or older contributed 92% of COVID-19 deaths, whereas individuals aged 44 or younger only contributed 2%. This gives insight into what age groups we should be paying attention to when it comes to treatment for COVID-19. For my third insight, I found that 73% of deaths from March 2020 to March 2021 were endured by people suffering from a prior condition. This was insightful because it shows that those with underlying medical conditions are at a higher risk of dying. For my fourth insight, I looked into if the states with the highest death toll as of March 2021 also had the highest population in 2021. And by looking into this, I found that the same 5 states with the highest death toll also had the highest population. This was insightful because it shows that there is a clear relationship between state population and state death toll, and can help explain the results of the first visualization where California and Texas are shown contributing the most deaths. For my final insight, I looked into whether there is a correlation between state population density and state death toll, and found the value of 0.2843 for the correlation coefficient between these variables. This value is insightful because it tells us that although state population density and state death toll tend to go up in response to each other, the relationship is not very strong. So for my third visualization, I decided to make a scatter plot showing the correlation between population density and death toll for each state, and this was meant to accompany Insight 5. As you can see, there is a weak positive linear correlation between state population density and state death toll. This is insightful because it indicates that utilizing more resources to combat the spread of COVID-19 in states with high population densities may be helpful in reducing the increase of the national COVID-19 death toll. And then for the summary file, I first grouped my data by state and then applied the sum aggregate to find the total COVID-19 deaths and total 2021 population for each state. So I have all of the states listed with the values for each sum shown. I felt that this was a good summary of my data because it shows two important attributes of the data. So overall, most of the factors I studied did affect COVID-19 mortality, and each insight showed the relationship between some of these factors and mortality. For instance, I discovered a weak positive correlation between state population density and state death toll. Some new material I worked with during this project were the date-time module and the Pearson R function. My greatest challenge during this project was figuring out what insights to generate from the clean datasets. Thank you for watching.